and welcome back to another biochemistry episode. Today we're talking about ELISA, which is a biochemical method to detect specific analytes like viruses. ELISA is an acronym and stands for Enzyme-Linked Immunosorbent Assay, and it's nowadays one of the gold standards in allergy research and diagnosis. As indicated before, it's used to detect analytes, which can be specific proteins or also complexes. And the detection can be made in qualitative and quantitative ways. Qualitative means that we can make a yes-no distinction. So we can say if someone is infected with, for example, HIV or not. Quantitative ELISAs, however, they make it possible to ascertain the concentration of the substrate. So, for example, how many antibodies someone has, or antigens, or also viruses. Now we want to talk about 4 types of ELISA: direct, indirect, sandwich, and competitive ELISA. Let's start with the direct ELISA, as it's the most easy one to understand. First, we immobilize the antigen on the plate. Then we add the solution, which could be a serum of a patient, which might contain antibodies. Here, the antibody gets directly labeled with the enzyme, therefore the name direct. And as soon as the incubation time is over, if there was antibodies, we see a reaction by the color change. So here the color changes from grayish blue color to green. Now about indirect. The principle is the same. So again, the antigen is immobilized on the plate, and then the solution might contain antibodies is added, and they are incubated. In general, you might want to add a solution with non-reactive proteins to cover the antigens that are unbound. And after this incubation time, you have to add a so-called primary antibody, which has an enzyme attached to it. And then we add the substrate for the enzyme, and this then leads to a color change. Now the sandwich ELISA. The essential difference here is that not the antigen, but the antibody gets immobilized on the plate. And then again, the solution is added before adding the primary antibody. And again, the primary antibody is enzyme-linked. This type of ELISA is more specific because the analyte has to be bound at different so-called epitopes. So epitopes are the places where antibodies bind. And this actually increases accuracy. And now let's talk about competitive ELISA, which is maybe the most complicated one to understand. The antibody is immobilized on the plate, then the antigen is added. This time we have the antigen once labeled, whereby we know how much antigen we add, and once unlabeled, and this is the amount that we don't know. If we take a look at the first drawing here, we see that the color is rather dark after the reaction. A darker color means that not a lot of antigen was in the probe, as the antigen did not compete with the labeled antigen that we added. So, if we have, on the contrary, a relatively bright color, there were many antigens because they were able to replace the labeled antigen. Maybe you might want to take another look at the drawings, then the principle might get a bit clearer. A typical application of ELISA is to determine the antibodies within the serum of someone, for example, to detect HIV. It's also feasible to use it for identifying potential food allergens or also toxic compounds. At the moment, the most essential application is to look if someone has antibodies against SARS-CoV-2 for those who've already suffered from COVID-19. This was a quick overview of the technique ELISA. I hope you enjoyed this video. If so, give it a thumbs up. Don't forget to subscribe to the channel to see weekly uploads, and